Hello, welcome to Block 3, Equality and Equivalence, Lesson 3. I'll share my screen. So, in your previous lesson, you learned how to find fact families from bar models and how to use them. In today's lesson, we're even going to make more effective use of those fact families to solve one-step linear equations involving addition and subtraction. So it's going to be an interesting lesson. But before we start, I would like you to do this retrieval practice, or some of you call it starter. You can pause the video and do this starter for 4 minutes. You could take shorter, you could take longer, work at your own pace. Now, if you take a careful look at the questions, you will see that these questions, it covers things we did a few lessons ago, even I'll say week 2 or week 1. So really think carefully about this. If there are some questions you don't understand here, then you may need to go and watch earlier videos from earlier blocks of learning. Okay, assuming you've paused the video and you've worked through these questions, here are the answers. Let's discuss them. So for the first one, you were told to write the fact family for the bar model. Okay, remember, for bar models, we always add the bars. So 15.3 with K here means we can add them. And then the 19 is just a whole bar. So that's our very first fact, that the whole bar of 19 is the same thing. Of course, you can see it's the same length or is equal in width to the whole bar of 15.3 at K. Now, addition is commutative. If you don't know what that word means, you may need to go and watch our earlier videos, but I'll tell you, commutative means it doesn't matter. Addition is commutative. It doesn't matter how we swap the K and the 15.3 around. You can see here, they're the same. They're the same thing. Okay, we have done the addition facts. What about the subtraction facts? The subtraction facts mean 19. If we have the bar for 19 and we slice off this bit for K, we're left with 15.3. So that's what's written here as an equation. So 19 minus K is equal to 15.3. And then the other fact is, if we slice this bit off from the 19 bar, which we can write as 19 minus 15.3, we're going to get K. Yeah. So these are all the fact families. This is the fact family for this bar model. And of course, if you understand this one, you can write fact families for addition and subtraction for most bar models. All right, question 2, you ask, which of the equations below does not belong to the same fact family? All right, so we can clearly see that for a fact family that is telling us that 9 is equal to 275 plus t, we can rewrite that so we know these two, these two should be correct because they are showing commutativity, so they are commutative. And then if you think about fact family, we can also write 9 minus 2.75, okay, a bit like this one on top, equal t. And then we can rewrite the other way. If we take the slice off of t, 9 minus t is equal to 2.75. So this one is the odd one out. And then question 3, you're told work out the input for the function machine. Okay, in earlier lessons, we learned that if we have the output and we know the operations in the function machines, we can do inverse operations. Inverse operations in everyday language, you say the opposite, but don't use the word opposite, okay? The correct way to say it is inverse, okay? So you do the inverse operation working backwards to get what the input was, and that's what is going on here. So instead of subtracting 7 going that way, you do 17 add 7 going that way. So halfway you write your result so you don't forget about it, and then you do 24 divided by 3, because going that way from left to right, you times in by 3. And of course, don't remember, for a function machine, we're always working. You'll see most function machines showing that you're working from left to right. So your inverse operation will be from right to left. Okay, let's do some new learning. If I give you this bar model, okay, how many facts can we write? Have a think. How many facts can you write? Of course, yeah, we can represent these. Yeah. Which fact will help you work out the value of k? Which one? It's clear that it's this one. It's really obvious. Yeah, that one. Because we're saying 19, we slice up 15.3 from 19, from the 19 bar, we're going to get k, because that's what's going to be left. All right. And so k will be 3.7. Now, let's solve an equation. So, which is the actual thing we're doing in this lesson. Let's solve an equation. So how do we represent this equation as a bar model? And then from the bar model, we're going to write the fact families, and we'll try to write a function machine. So let's check this out. Let's see what we can do. So as a bar model, we can write it like this. Yeah. So the big bar obviously will be 17.3, right? And then we have x, because that's what it's telling us. If you just think about it, common sense, you figure this out. You say, okay, that big bar must be 17 at 3, 17.3. And then these two bars should be x plus 8.4. The size does not really matter because we don't know what x is, do we? We don't know. So I want you to think, how many fact families can you write from this? So pause and write your fact family. How many of them can you write? Remember, for this, you can write 2 addition and 2 subtraction. I'm just giving you a hint. Okay, I'm sure you would have come up with these. Yeah, so the first one that is really obvious is the equation itself. Yeah, 17.3 is equal to x plus 8.4. And then remember, addition is commutative, so we can, swap 8.4 and x. Okay, and this will be the second one. That's fairly obvious. And then the subtraction, the way to do it, you can say, okay, what if I can take a slice of x from 17.3? Yeah, how do I write that? I can write that as 17.3 minus x equals 8.4, because that's what is going to be left. That's how you would write it as an equation. If you slice off that bit, and it's the same for the 8.4 bit, you say, okay, if I can slice off 8.4 from the 17.3 bar, I'll be left with x. So the way to write it as an equation will be 17.3 minus 8.4 is equal to x. Now, if you take a look at it as a function machine, yeah, we're putting in x, we add 8.4, we get 17.3. That's what this equation is, right? So remember what we did earlier. If you have an output, but you're looking for the input for a function machine, what do? Drum roll, what's the word? Inverse operation, right? So we do that. So instead of adding 8.4, we do subtract 8.4, and we get exactly the same result that we'll get here. Okay, so solving equation means finding the value of x. X is usually written, but if you see any other letter like A, B, C, D, who knows, right? Any letter. Remember, in maths, we love using letters to represent numbers we do not know. Okay, so if you go and watch one of our earlier videos, we had discussed all this in our study of the basics of algebra. Okay, now that you have learned these, I would like you to have a go at questions 1 to 4. So pause the video for about 4 minutes and have a go at these questions, question 1 to 2. Assuming you've paused the video and you've really thought about these questions and you've worked through them, here are the answers. Let's discuss them. So here, you're given a bar model and you are given the fact family to complete. So this one is obvious. 163 should be W plus 78. And then the other fact family is showing that it's commutative. You can swap the 78 and the W around, you'll still get the same result, right? And then here, you're being asked which fact family, which one of the fact family will help you find W. Is obviously this one. Because remember, if you are after this bit here, you need to think about slicing that bit off so that it goes away. And that represents, yeah. So if you're after the size that is matches the W, is a bit like saying 163 slicing off 78, and that's represented as 163 minus 78. So this one is what we can use to find W. And then the answer is that one. Here is the answer for question 2. Question 2, you asked, write the fact family for the bar model. Again, this is the basic one. 205 is that plus that. Yeah, and then you can do the commutative one, which is swapping it around. Yeah, and then you can do the slicing off bit. So if I do 205 slicing off 128, I'll get x. Yeah, 205 minus 128 equals x. Yeah, or 205 minus x slicing off x will give me 128. Okay, which are these? Okay, and what is the value of x? Of course, you can do that. Okay, you can do that using simple arithmetic method, which you learned in SATs, or you use your calculator. Here are question 3 and 4. Pause the video and do it in 4 minutes. Okay. Assuming you've paused the video, you've really thought about this and you've worked through it, you've worked hard, here are the answers. Let's discuss them. You're asked to draw a bar model for this. Yeah? Y plus 39 equals 72. Of course, by now you should know 72 is the big bar. And then because you always add bars in the bar model, is one bar will be Y and the other bar will be 39. The size does not really matter. We do not know the actual value of Y. We don't really know. Okay, but just make sure you draw it properly like this. And then write the fact family for your bar model. By now, you should know how to write the fact families. And then you find the value of Y. Okay, here is the answer to question 4. You're asked to solve the equations. Okay, so by now, you should already know, after you've used the bar model for a while, some of these questions, you can actually do it in your head. You know, okay, I need to do this minus this to find D, or I need to do this plus this to find F or C, whatever the letter is. So here are the answers. Okay, so if you are not sure about how fact families work or how to find the fact family and how to use the idea to solve this problem, you can go back to the previous lesson, which is lesson 2, to gain a deeper understanding. Okay, what about this one? If it involves subtraction, what can we really do? How do we represent this? Think about what you learned from doing the addition fact family and the bar model. So if you think about it, 29 looks really large and we're taking away B from it, right? So where would we put the 29 at 3.3? And what will be the fact families? Have a think. Okay, of course, it's going to be the big bar. And so one of these bars will be B and the other one will be 7.8. Okay. And then the fact families are these. So this is the most basic one. 20, the big bar is equal to these two bars added. And then we can do the commutative one, which is swapping the 7.8 and the B around. So which looks like this. And then you can do the subtraction. Yeah, subtraction is one of them, is already here. All right, so 29.3 slicing of P will give us 7.8. Guess what? Drum roll, the next one is 29.3 minus 7.8. So slicing that off will give us P, which is what we're looking for. Right? That is 21.5. Okay, let's do some thinking. Amir draws a bar model for the equation r minus 72 equal 23. Here is what he drew. Yeah. So he thought, oh, 72 is a big number, so if we draw it like this, it could seem right. But think about it. Is it really right? Yeah, he says the greatest value goes in the largest part of the bar model. Really? You sure? Well, not quite. Because it should actually look like this. Remember? R minus slicing of 23 will give us 72, or R minus slicing of 72 will give us 23. But if we go back to what he did before, this is what it's going to be. It's like saying 72 slicing of R, which does not look like what was given to us to solve. Okay, so it's really important you think about how you solve problems properly using the bar model. Okay, have a go at the rest of the questions. Pause the video for 4 minutes and do questions 5 and 6. Assuming you've paused the video and you've worked through the problem, here are the answers for question 5. So here Rosie has drawn a bar model to illustrate the equation 60 minus h is equal to 19. So here is what Rosie drew. Okay. What mistake has Rosie made? Draw the correct bar. So this is what the bar should look like. 60 slicing of h is equal to 19. So h and 19 should be in two separate bars next to each other, while 60 should be the big bar. And then here is the answer to question 6. Question 6 asks, draw a bar model to illustrate g minus 59 is equal to 12. By now, you should know g should be the big bar, right? Okay, and 59 and 12 should be the other separate bars. And then you should know how to write fact families by now. And then you know the fact family that should give us G is this one. Okay, you should know, this one, the fact family that should give us G, that one. Okay, pause the video and do question 8 and 9 in 4 minutes. Assuming you've paused the video and you've really worked hard, well done, well done. Applause to you. You're building really good foundation in maths. It's going to pay off. Okay. So here are the answers. So the answer to question 7 is this. So you're asked to solve the equation. So again, remember, to solve equation means you should work out the number that represents that letter there. So you can use the bar model to think about what facts, okay, and which one of the fact family will help you get the result. Okay. All right. So let's move on. Here is the answer to question 8. Here we ask, write an equation for each of these problems. So Whitney thinks of a number. Of course, remember what we said in maths. If you don't know something, you represent it with a letter. So we could have said X. Yeah. Thinks of a number. She adds 87. You can see X added 7 to her number and gets an answer of 153. Straight away, that's what the equation should look like. Yeah. And then you ask to solve the equations. And then Tommy thinks of a number. He subtracts his number from 302.1. Remember, we did not subtract 302.1 from his number. We subtract his number from. So it should be 302.1 minus x equal to 149.8. And of course, you can use your bar model to represent it and then write your fact families and determine which fact family will help you solve the problem. Okay. So this brings us to the end of our lesson. What have we learned so far? So far, you have learned in this lesson that you can solve equations involving addition and subtraction using your bar model and then using your fact families to solve those problems. Okay. A very important aspect is for you to understand how to build your fact families from your bar model. Okay. Until next time, take care and bye-bye.